So today I'm going to talk about the relationships between water quality and production, particularly livestock production. So the two questions, I'm going to slide in a few small ones along the way, but the two key questions that I want to talk about today is how can production impact water quality? And then secondly, how can water quality impact production? So I'll come back to those questions, but first of all, I just want to give a very brief overview of what a riparian zone is. I'll be using the term throughout the session, so I just want to make sure that we're all on the same page. Riparian zones are those lands adjacent to streams, rivers, waterways, dams, wetlands. So it's the land, the terrestrial land adjacent to those waterways. They're periodically inundated. And because they are those sort of damper areas of the environment and usually downslope, they tend to have a lot more organic matter, a lot more richer soils because they've been flooded over time. And so they're the very productive areas of our landscapes. So they're ecologically, socially and economically important. So obviously economically in a production landscape, they are the richest parts of our lands, and so there's production values associated with that and a lot of stresses because of them being the richest areas of our landscape. They also have a lot of social benefits. People like being around water. It's important for our recreation, it's important for our psychology, and so these are the areas that we stand on when we're fishing, when we're launching our kayaks, when we're picnicking by the river. And ecologically, these are critical parts of our landscapes because they do mitigate or filter between the terrestrial zones and the aquatic zones. So the sediments, the nutrients coming off our hill slopes are filtered by those plants that are on the riparian zone, and that helps reduce those sediment and nutrient loads into our streams. And that helps maintain water quality. As well as that, the riparian vegetation that grows, so the trees, the shrubs, the emergent reeds alongside the water, those roots, that root mat helps to stabilise the banks so that root strength holds the banks together and decreases erosion. Because it's creating roughness in the landscape when we get runoff from rainfall, then that vegetation slows the movement of water. It has an excellent benefit of keeping the topsoil and the sediments where we want them on the landscape, and that promotes production and biodiversity values, and it prevents it from going into our aquatic systems where it becomes a problem. And obviously they're really important parts of the landscapes to animals as well, and plants, and the trees, the woody debris, so the trees, they get old, they get hollows, that's very important. They lose branches, and that woody debris, when it falls into the river, creates habitat for fish and other species. When it's on the bank, it's creating a habitat for reptiles and other species. And so these zones support very high levels of biodiversity. So how do livestock impact water quality first? And as Deb was saying previously, there hasn't been that much work done in Australia, but we do have research that we can draw on from North America, the UK and also New Zealand. And so a couple of studies found that this first study was from the UK, and it found that cattle, the percentage of time per day that they spent in rivers was about 2 to 3%, but 7 to 12% of their daily time was spent within the riparian zone, so sheltering and grazing in that zone. A study from Massey University in New Zealand found that in hilly country they actually spent for longer, so up to 6% of their day was spent in those stream environments in hilly country. The time varied among individual cows, but also it significantly increased with temperature. So the hotter the day, the more the animals were coming into the streams to cool off, drink water, and then they were spending time in the riparian zone trying to make use of the shade. Studies have also shown, and this is the study that came out of the UK, that cows standing in water defecated 5 times more frequently than if they were out in the adjacent paddocks. And so for that particular study, less than 1 kilometre of stream length, so it was only 770 metres, 33 cattle deposited 8.4 tonnes of faeces within 7 months of that study. And so we know that coming with the faeces, there's nitrogen, there's phosphorus, there's potassium, and there are also contaminants and bacteria. And so we can see here from the photo, this is sort of down southern New South Wales on a dairy farm. We can see that the effects of unrestrained stock access to the river, they've grazed, they've trampled, we can see active eroding beds, and the water is a little bit turbid. So we lose our riparian vegetation with unrestricted stock access, both with them grazing and also the trampling. So you'll see where they sort of preferentially go down to the water, that they're starting to trample the soil, they're compacting it, and we don't get regeneration. And if things do regenerate, then they're being grazed off. Because of that compaction and that loss of vegetation, we see erosion around those stream banks. As well, the lack of vegetation, particularly in an area like Armidale or the northern Tablelands where it's colder. If it doesn't have the vegetation, then the soil is more exposed during the winter months, and so we get a thing called frost heave, which is where the moisture in the surface area layers of the soil actually freezes because it's a frost, it's below freezing, and so those water molecules expand and kind of heave off bits of the soil, and so you'll see slumping banks after that. And so if we did have vegetation, we have trees, then we have protection. They create a temperature microclimate and give us protection from that frost. Because we're eroding the sediments around the banks, then we find we get a lot of sedimentation in rivers. And so if you've sort of walked along a river or kayaked along a river, and you'll see a nice cobble bed or gravel bed stream, and then where you see unrestrained stock access, you'll see a lot of fine sediments and silts and clays. And so when that's excessive and more than what the water can flush away, then you see that the cobbles are completely smothered by those fine sediments, and so that's a loss of habitat to all the little animals and plants that would grow on those cobble beds. When the sediments are suspended into the water column, either because the flow is flowing fast enough to be able to take it, or the movement of stock through that system is resuspending that sediment up into the water column, then it increases the turbidity of the water. And so turbidity is a lack of clarity, if you like, because there's suspended particles in the water. A lot of predators, such as fish and birds, are visual predators. So they actually look around and see their prey. And so when turbidity increases, then they can't find their prey as well. They're less efficient as predators. We know that when turbidity increases in rivers and gets to sort of higher levels, then it actually can start to smother the gills of fish. And even though it might not be at a level where it affects their survival, it creates physiological stress, and so we see sort of higher incidences of pathogens and parasites, and lower sort of fertility and recruitment in those systems. As well as that, you kind of get this double whammy. You've lost the trees, and so we don't have the shading from the trees, we don't have the thermal protection to those streams. But as well as that, we've increased turbidity because we've got those sediment inputs coming in, and when the sun hits those more turbid waterways, then those particles that are suspended in the sediment, in the water column, actually absorb more heat. And so turbid water, for the same amount of sunshine, is hotter than clearer water. And so as we increase our turbidity in summer, we can also increase our water temperature. And we're finding that there are three critical thresholds in water temperature. So things like fish that start to see major pathology and sort of reduced viability at about 30 degrees Celsius. And so when we fill in those pools from the sediment, then we've got shallower water, it's heating up, and so we're starting to get closer and closer during summer to having these temperatures. At higher temperatures, the sort of enzymes in the, that regulate the metabolism of the fish are starting to hit their critical temperatures at which we see higher disease and higher mortality. Dissolved oxygen, also the water can actually hold less oxygen as it heats up. So colder water can hold more oxygen. And so in summer, as we see those pools start to heat up, then the water physically cannot hold the oxygen, and so we start to see lower levels of oxygen. You might see fish kind of gasping at the surface. And so all of these things can result from a lack of shading and an increase in turbidity. And we lose the thermal refuges that we had when we had those deeper, clearer pools that were shaded. If cows are defecating in the stream, they're directly adding inputs into the stream. But even when we see them out on the bank and when we're having nothing to filter those sediments and nutrients coming in, then we have a lot more sediments and nutrients coming into the stream. A lot of Australian systems are actually adapted to sort of relatively low levels of nutrients. So these are the macronutrients, nitrogen, phosphorus, carbon, that are critical to support plant growth. And so our streams are adapted naturally to low levels of nutrients. And so when we artificially increase the nutrients, particularly of those macronutrients, then we'll start to see algal blooms or nuisance growth of invasive species. And the other thing that studies have shown is that when you give stock unrestricted access and they're defecating in the streams, then you're actually significantly increasing the pathogen and parasite load for further stock downstream, so whether that's on your property or on the next property downstream. So how does good water quality impact livestock? So if we exclude stock from riparian zones and then use an off-stream watering system such as troughs where the water is pumped up from the river, then clean water and reducing that stock impact or access to their water supply reduces the fecal-oral transmission of diseases. And so studies have shown that bacteria such as leptospirosis, cryptosporidiosis, in some places Giardia, and also the incidence of mastitis in cows have been significantly reduced when stock were taken out of the streams and watered off-stream. They've also noticed that cows actually drink more clean water, and so there's a palatability issue where they prefer clean water. And because they're drinking more water, then they're consuming more organic matter, which means that a study has shown that there was a weight gain of 5% when they were drinking off-stream supply of water, so out of a trough, rather than in the stream. So that study came from North America, and that was for beef cattle. And so a 5% weight gain, it didn't specify the time. But they also found that for milk cattle, it actually resulted in an increase in the fat content of the milk. And so it increases the actual production, whether that is biomass or beef weight gain, or whether it's milk production. And they don't have to wander as far to get the water, depending on how you place your troughs. So they're not losing that sort of metabolic activity to walking around and searching for water. And so they're grazing more and resting more. And so that energy is going into biomass and production. As well, if we remove stock from the water, we're removing that direct nutrient input into the stream, and so it reduces the risks of toxic algae. And so as Deb was saying earlier, we've got some toxic blue-green algae, and when the nutrients get out of sync, these particular algae, they can fix their own nitrogen from the atmosphere. So we know that the nitrogen in the atmosphere is sort of 72%. So there's enough, it's unlimited for them to be able to fix nitrogen. And so if they have high phosphorus and unlimited phosphorus, then they can fix as much as nitrogen as they need. And so we get this sort of unlimited growth of toxic algae. And because they can fix their own nitrogen, they can outcompete the greener algae that are sort of less toxic. When those algae blooms die off, then those algae sink to the bottom and start to decompose. They're very easily decomposed, if you like, very simple structures, so the bacteria can get in there and decompose those very, very quickly. The bacteria that do that are aerobic, so they actually consume water, oxygen out of the water column. And so what we see as an algal bloom dies off is that the microbes go ballistic because they have an unlimited food source, and then they suck all the oxygen out of the water, and then we start to see sort of fish deaths because of low oxygen or anoxic conditions. As well as that, when we have actively eroding banks, and we have very unstable, steep slopes, and so they've shown that if you sort of remove the stock from accessing those banks, and you kind of remove the incidence that they're having to traverse those unstable steep banks, then you're reducing your deaths from sheep or cattle losses. Calves in particular sometimes can't really navigate those slopes, and so lambs and calves are more likely to be lost, and even cows or sheep during the lambing or the calving. You obviously have reduced deaths from flooding, so your cows can't get down there into it and be swept away, and so that's a benefit. But you also have reduced biosecurity risks because you don't have stock wandering off your property or other people's stock wandering onto your property. And so when stock are accessing riparian zones, those fences are having to be replaced often depending on the flooding, or they can be difficult to maintain down into that steep bank and across the river. And so you have that movement of stock that is uncontrolled and leads to a biosecurity risk. And if we over a longer period of time of excluding stock from riparian zones, then we can build up healthy riparian vegetation. In some cases, that vegetation might already be there, and by fencing it off, we've stopped it from being grazed and trampled, and so we can get that natural regeneration. In some cases, if we've lost a lot of our natural vegetation, we might actually have to plant native vegetation to build that riparian vegetation up. But if we do that and we end up with a healthy riparian vegetation, then, as I said before, it's roughness in the landscape. So as we get rainfall generating runoff over the landscape, then it's actually holding that water back and allowing it to stay on the property longer before it flows into the streams. And because it's holding the water and slowing the water down, it's also keeping those nutrients and those fine sediments, those silts and those clays that are the nutrient rich. It's keeping it on the property as topsoil, which is where we have the agricultural productivity and biodiversity benefits. As well as that, it can a healthy riparian zone acts like a shelter belt, if you will. And so even though the stock might be excluded by a fence from the riparian zone, they can be adjacent to it. And so within a landscape where you have those sort of dense trees at about 20% porosity, so with trees and shrubs, and so your a denseness there, it actually slows the sort of regional wind pattern or the wind flow over the property, just as a shelter belt does. And so by improving shade and shelter for your stock, those benefits are to improve their fertility and conception rates, improve survival during lambing and calving, because they've got those sort of warmer microclimates that are less exposed to temperature extremes. Because they're not expending so much energy in having to maintain their body temperature, then they're putting more of that energy into wool, meat or milk production. And as Deb was saying, those riparian zones serve critical ecological functions, and so they provide those ecosystem services by supporting healthy populations of pollinators and species that control pests. And so you'll find lots of birds and bats and reptiles and spiders in healthy riparian zones that are insectivores, so they're eating pasture and crop pest species. And because you've got those root mat and you've got that roughness on the landscape, it's, as we said, it's slowing the water down and it's holding the soils together. It's increasing the organic matter and holding those soils together, and so we see less erosion, which means less of those topsoils down into the water column, where it creates issues for our native fauna and flora. Interestingly, recent work down in Victoria has shown that they're really useful carbon sinks. So when farms are trying to look at carbon sequestration, this is actually a study that they referred to that was done in the Condamine, so in southern Queensland, where the riparian zones, and this was an average, they looked at poor, good and excellent riparian zones, and on average 120.8 tonnes of carbon per hectare were stored in those riparian zones. So obviously the healthier riparian zones had a lot more carbon, a lot higher carbon stored in those systems than the degraded riparian zones. But that's in comparison to 76 tonnes of carbon per hectare for a nearby forest, eucalypt forest. So that's a significant contribution of carbon storage on a farm landscape, and it's particularly beneficial when you can have those healthy riparian zones and have that diversity of carbon. So you've got carbon stored in trees, in roots, in shrubs, in timber, and so and also in the organic matter being stored in the soils and the reeds on the fringing vegetation. And so it encompasses a lot of different types of carbon being stored within those small areas. So how do we improve riparian zones? We know they can have benefits to our livestock production. We know they're important ecologically and socially. So how do we improve them? And obviously we've talked about fencing and excluding stock from riparian zones. We've also talked about the importance of establishing off-stream water supply. But if we've got pumps, if we put screens around the pumps, and so that we're not sort of getting fish and platypus, if they're large pumps in particular, they're not being damaged by sort of going into that. Leaving logs and woody debris in streams, so there was a kind of concerted effort decades ago to remove it all out so that the water could flow away quickly, and when we did that we removed a lot of important habitat for our native fish species. And so leaving those logs in, as well as that, if you've ever had a chance to sort of kayak down a river and observe, you'll notice that if a tree kind of falls in the river, then, and this is a generalisation, but it's common, it falls in and the flow of the water kind of moves it downstream. And so as it falls, it actually then buttresses the bank going downstream, so longitudinally buttressing the bank downstream and protecting that bank, and so allowing it then to sort of re-establish with vegetation and become more stabilised. And so leaving those large woody debris provides habitat and also can help with stabilisation. Weed control is really important, especially if we're moving stock out. And when we say to exclude stock from riparian zones, there are actually grazing management practices where you can graze a riparian zone. In some cases it's helpful to do that for weed control, and it's well worth talking to your local land services, because the type of strategy that you use will depend on your soils and you know, your stocking rate, the types of your riparian zones, your pastures. So all of those things will kind of influence the best kind of grazing frequency and intensity, and so it's well worth talking to LLS, and they can guide you through those different grazing strategies. But because there is vegetation and grasses and ground covers there, some of these riparian zones have been really important drought refuges, so they can be grazed and help sort of get people through a little bit longer through a drought. But obviously the important thing is then that you don't trash it for later on. So weed control is important. Rivers are excellent vectors of weed, so those seed pods just keep going down. In some weeds populate vegetatively, so little pieces of them break off and then they can re-establish downstream. And so there kind of needs to be quite regular weed control in riparian zones, especially if sort of upstream neighbours haven't done weed control or have weeds in their properties, then there'll always be a source of weeds coming in. In some cases, as we said, if there's been a loss of native vegetation, native trees, then vegetation, revegetation might be needed. So going in and planting and protecting those plants. If there are weirs or dams, then having little fishways, so allowing fish movement, and same thing for causeways that can stop fish movement. And it's really important to know what you can do, and going to your LLS will sort of help you unravel all the different government departments that need to or regulate what can be done in streams and rivers. And pest control, obviously. So foxes in particular can use riparian zones. That you'll often see a fox den sort of in a steep bank, and also rabbit dens. And so doing pest control is important. Obviously, allowing enough water to go down the river is important as well. So the New England Tablelands has just gone through a severe extended drought, and then followed by bushfires, and then followed by flooding. And so it's kind of the vegetation cover was the lowest it had been, you know, for a very long time, particularly when those riparian zones were dried out and didn't work as control zones or containment lines for bushfires. So we saw fires move through areas that previously would have pulled them up. And then we had floods, and so you had sort of the lowest possible organic matter and vegetative cover and roughness on the landscape, and then we saw sort of a lot of silts and sediments get moved and topsoil lost into the streams and rivers during those floods. And as well as that, during the drought, what we saw is those pools disconnected, and so obviously there's less water coming into the system, and so you start to see sections that were flowing disconnect, and so those pools can become refuges for animals until a certain point, and then, you know, they've been disconnected for so long that there might not be enough food, or the water quality starts to really deteriorate, and so they kind of shift from being a refuge to a coffin, and so it's, you know, a lot of research is being done, you know, on trying to predict that, and fisheries spend a lot of time sort of going around those streams in the northern Murray-Darling Basin and also on the northern rivers, and trying to rescue and relocate fish species that were endangered but had been sort of in these refuge pools, and then those refuge pools were drying up. And what we saw was that because those pools were disconnected for so long, you start to get organic matter, so trees were losing a lot of leaves because they were in drought stress. And so when it rained and those rivers connected again, a lot of organic matter had built up in those dry channels, and so it got re-wetted all at once. Wasn't quite enough flows yet to sort of move it far downstream, and so what we saw was a lot of organic matter getting wet and decomposing very quickly. As I said, the microbes just go crazy and they consume all the oxygen, and so fish that perhaps had survived in some of these refuge pools and had survived in the drought, you know, then we saw fish deaths afterwards as those rivers reconnected, and it was simply the lot of organic matter and the microbial decomposition taking the oxygen out of the water. And so anecdotal evidence from property agents, and again this is sort of more southern New South Wales and Victoria, but that anecdotal evidence is that a well-managed riparian zone can add about 10% to the property value, and so there's well worth sort of maintaining those, not just for the benefits that you get now, but if down the track people need to sell, then those who are looking for properties are looking to see good land management, and that's an indication of good land management, good water management, and also, you know, somewhere where they can go and enjoy the river. So there's a map of the major New South Wales rivers and a quite badly drawn representation in red of the northern tablelands. And you can see that we sit there on the headwaters of both western and eastern flowing rivers. So to the left, we have the western flowing rivers that feed into the northern Murray-Darling Basin, the Jumeric, the McIntyre, the Guido and the Namoy, and they all feed down into the Darling. And then on the east, we see the headwaters of the Richmond, the Clarence, the Macleay, and a little bit of the Hastings down past Walker, sort of down towards the Oxley Highway. And so we can actually do a lot, either good or bad, for an awful lot of catchments, because we sit on the headwaters of so many catchments. And if you think of many of our river systems, they're dendritic. So if we imagine a tree, and we've got the big stem, that's the stem that goes out to the ocean, and then up we've got the sort of the branches, our major river systems, and then we've got the headwaters, and they're like the little twigs. And so by stream length, headwaters are the vast majority of our stream networks within our catchments. And so because the northern tablelands sits on the headwaters of that many streams, there's actually a lot of stream network within the northern tablelands area. So this is an example of the Macleay. The Macleay is down the bottom right of the red patch. So the Macleay drains out, big coastal system, and it drains out near Southwest Rocks to the Pacific Ocean. And so this map on the right is the riparian grades that was done as an assessment of aquatic ecosystem health. And you can see that these little subcatchments, each little block is a subcatchment, and the subcatchments on the left of that map that are in the dark red are the ones that are on the northern tablelands. So they're the headwaters sort of near Armidale, near Walker, and up towards Gyra with the Gyra River. And so you can see that, and this is riparian zones, and so we have quite poor riparian condition across those headwaters. So these are the headwaters of the Commissioner's Waters, Salisbury Waters, to a lesser extent the Gyra River. So how does that affect the catchment? So this bottom map is the water quality grade, and again this is an assessment of the physical, the biological and the chemical quality of the water using those guidelines, the Australian New Zealand guidelines that Deb talked about, and how many times those guidelines were exceeded and by what order of magnitude. And so if we look at all of those things, we can see that those tableland headwater streams, and this is just one catchment that we sit on top of in the Macleay, and we can see that we had very poor water quality. Some of them are linked with poor riparian condition, and some of them we saw poor water quality even where riparian condition was okay. So what are the key drivers of poor water quality here? This is a very similar situation in the Clarence, which is the next sort of major coastal river up north of the Macleay. So this is a graph. It's of total nitrogen. So that's the total amount of nitrogen both in a particulate form and in a dissolved form. And if we have a look at the graph, the names along the sort of bottom axis that run horizontally at the bottom are the Gyra River, the Commissioner's Waters, Salisbury Waters, Apsley River, and we're heading then down into the gorges with Yarrawitch, Bakers Creek, Willamombi River, Chandler River. So it's all of those sort of key headwaters streams of the Macleay River. That red line that you can see towards the bottom of the graph is the Australian New Zealand guideline for what total nitrogen concentrations should be. So above that red line, that's the critical threshold above which we would start to expect to see declines in aquatic ecosystem health. And you can see that if we have a look at those bars, each river has, or each site on the river has its own bar, and that's the sort of range of values, if we like. If you can see those very, very small little red horizontal lines across each blue bar, that's the average concentration of total nitrogen that we found in that river. And you can kind of see by the spread of the blue bar and the lines sort of going above and below it, the range that we found. And some of those rivers were quite high differences between the minimum and maximum concentration. So they were very, very variable. But what we do see consistently across this landscape is that total nitrogen exceeds it by an awful amount. So it's a very, very high exceedance in both magnitude of the exceedance and also the frequency. So we see there are some sites there that were never below the critical threshold for total nitrogen concentrations. Oops. So this is total phosphorus, so another key macronutrient for both productivity on land but also for plant growth in water. And again, the same sites down the bottom from the Gara River and then heading down into the rivers that drain the tablelands into the gorges. And we can see to a lesser extent that again we had high exceedances of total phosphorus. So particularly Commissioner's Waters was very, very high with phosphorus, and then as we get down into those rivers into the gorges we saw lower levels of exceedance, but still well above the national guidelines. So here's a map that was pinched off New South Wales and Department of Environment. And it's having a look at a catchment and all the different things that that contribute to poor water quality or contribute to good water quality. And so we're sitting up the top, towards the top left of that diagram, up in the top parts of the catchment. So things that we can do is increase ground cover, so that's across the landscape, not just within the riparian zones. So trying to maintain sort of a more dense pastures is important, trying to sort of more biomass of grasses and herbs and forbs. We can start to look at using conservation farming techniques, so where there's tillage, sort of looking at how we're doing that in relation to the topography of our paddock. And there's a lot of other techniques that are being developed, and again, recommend that you go and talk to your local land services who are keeping up to date with what's working well in your local area. Again, we've talked about livestock management, so that's sort of management out of an exclusion from the riparian zones, but then also looking at perhaps our stocking densities and how we move them around the landscape. So whether we're grazing for a long time on a sort of patch of land, or whether we're looking at moving our stock around and giving those paddocks some rest. As we talked about, off-stream watering is really important because it's taking those nutrients out of the systems. It's also reducing the erosion and the compaction and increasing our riparian vegetation, either by letting it regenerate naturally because we have that sort of source species or individuals there, or having to plant it because we've already lost those out of the system. A really important one is to increase the connectivity of vegetation. And so when I say that, it's to, if you think of a landscape, you'll see patches of riparian zones. So if you're ever flying over the tablelands, you'll see sort of that darker green vegetation sort of curving in the landscape, and you'll see that is quite patchy across the landscape. So over time, connecting up those patches helps longitudinally with the reduction of sediments and nutrients into the stream, but it's also critically important for the animals that live in those riparian zones, so they can move over much larger distances when those patches are joined up. But also, not just joining up those patches of riparian vegetation longitudinally upstream and downstream, but also thinking about joining them up to that remnant vegetation we have in our hill slopes and floodplains. So sort of looking at the spatial configuration of our vegetation patches and starting to look at joining those up. And then also erosion control, and so whether that is looking at gully, sort of the development of nick points in gullies or head erosion, or whether it's stream bank erosion. There are different methods that work depending on slopes and soils and sort of how much water is coming down, so sort of how much area is drained by that little patch. And so there are a lot of different methods and help, so government programs that can sort of help finance the work on that farm. So that's it.
Thank you so much, Sarah. That was fascinating. Nothing made me cringe there at all.
Oh, that's very good.
I wanted to use that word. I know you like that.
Yep.
Look, I made quite a few notes as I went through, but that where you were coming to the end, I thought was really fascinating. I'm aware of a situation, let me give an example, where there's a new feedlot wishing to be established, and I know some residents, local residents, are concerned about spill off into the waterways. The feedlot, to give the background, is about 1 kilometre away from the water, but it is down a slope, but everywhere's down a slope, to a catchment area somewhere. What sort of general observations might you make about the land down that slope where any inadvertent spill off with heavy rains would be better? Is it better to have just a simple bund to go across, or do we need some plant growth, or what?
So this is an answer not having seen the site at all.
Oh, absolutely.
But I think general principles are that the closer the development is to the stream, probably the more care that needs to be taken, and depending on the types of soils and the slopes that are there, it might go from a simple bund if it's a relatively sort of flat area, sort of well away from the stream. But there's been some really good work done with feedlots where they've kind of got multiple sort of dams, if you like. So the first one is taking that slurry and that sort of sediment will then sort of sink to the bottom and settle out, and a lot of nutrients and contaminants will be absorbed onto those silts and clays. And then downstream of that, they'll have another one, and so that's taking sort of the next slot. And if that can be incorporated with a reed bed, so that as Deb was saying, those reeds, they really kind of take the nutrients out of the water and they turn it into biomass. And so sort of a multiple systems like that where you can, you're controlling sediments is a key one, nutrients is a key one, and then the water. And so, I'd certainly, the individual site will determine what decisions are made, but having a settling pond for the sediment and then trying to trap those nutrients and put them into biomass. And trees are good for that as well because they're deep rooted, so they're lowering the water table as well. And they're slowing, and shrubs are slowing the water movement down slope, and as well as all of that infrastructure to sort of prevent the water getting to the stream, then a healthy riparian zone with replanting, making sure that you've got good land or vegetation cover at different levels. So sort of you've got a shrub layer, you've got a good grass and forb layer, and then if you can get it, a fringing reed sort of between the trees or the plants, terrestrial plants and the stream. There's sort of lines of defence, and so in a good year, it might be the settling dam and the next dam where the nutrients are, and you don't see anything downstream of that. Yep. But then you have a very wet summer and you're starting to really rely on the next lines of defence downstream.
That's great. Thank you. No, it wasn't meant to be a specific on any one place, because earlier on when I was talking to Todd, we were talking about the potential for containment feeding as being something that we're seeing more of on properties where no licences are required, but people are putting large numbers of animals through their own sort of private yarding. So I'm assuming therefore that we have to take the same precautions with that?
I think would depend, on like obviously if you are concentrating stock and you're starting to see, a degraded ground cover, which you would if they're concentrating around troughs and they're trampling it, you're getting compacted soils and you're not getting those grasses growing, then I think it does become really important to look at increasing the roughness and the biomass elsewhere on the property. So, there are benefits to concentrating production if you can protect the rest of the landscape. So, we've all seen paddocks that are too highly stocked and they're completely flogged out, and it will take an awful lot of effort to even bring the grasslands back, let alone the riparian zones. And I don't know, I think there would be good examples of more intense, smaller sort of production, but where they've really taken into account sort of the downstream effects of that, and they've put those protections into place. And so less of the land is being used for production, but they're putting sort of energy and effort back into building up those healthy riparian zones, and even the hill slopes that are leading into them.
Yep. I mean, I think you rightly pointed out there are grants available to help people to develop, and LLS, not me, but other folk that I work with know more about it than I ever will. But we can help people with stopping erosion, etc. One of the things, however, you talked and gave that interesting data on nitrogen and phosphate sort of levels, which were frightening really when you look at them. Are those long-term, and how do we tie that in with the drought sort of situation where people are desperate to hang on longer and longer just to save a few pennies, well, a lot of pennies?
Yeah, look, I think, anyone that was sort of based in any rural area in Australia through that last drought, you saw the desperation. You saw the desperation in people, you saw it in fauna, in stock, and in the trees, and it was... I didn't let my mum come down and visit me. I said, it'll break your heart. I don't want you seeing the landscape like this. So I think we're always going to have those extreme events, and perhaps, they're going to become more frequent. I think there's a danger in looking at them and then relaxing during the good years as well, because that's when we can actually put in those protections. We can get those trees established. We can sort of build up our stock, and we can start to take the measures that will get us through. And so there were farmers that did get through the drought better and for longer, and they'd put a lot of effort into sort of protecting their property. So good fencing, good watering, manipulating their stocking rate, and kind of seeing ahead. And I grew up on a dairy farm, and during when it was deregulated and during a drought, and I think it's easy to stand back and judge people. I think the margins of profitability are so low that we have to have a long-term view, and so we have to start, because we know that it's going to be hard. There's always going to be those horrific droughts, and then those big floods. That is the nature of farming in Australia. So I think it's really important then that in the better times, the good times, if property owners can come up with a vision and then incrementally try and get it there. It's not going to be something that happens overnight, but I think what the drought did show is where people have invested that way, they were rewarded, and they came through it much, much better. And so now that we've had better rainfall and we can kind of, the bushfires have stopped, I think now's the time. There's bushfire recovery funding, there's drought relief funding. So there are a lot of schemes available now that farmers can use. And perhaps, if the fences were all burnt, now's a great time to think about, how you would reconfigure your fences to make use of some of the more modern farming methods and grazing methods that have been shown to really improve sort of pasture and production.
Great. Look, I'm totally in agreement with you. I'm going to finish it there. That sums it up nicely. Thank you so much, Sarah. Lovely talk. Thank you.
Thanks.